a brief outlook of our agenda for today's webinar. I will start with an introduction to the Cardimed project, which is the project that powered this webinar and inspired the idea behind it, and then give word to our four speakers, who are Simos Malamis, Associate Professor at the National Technical University of Athens and the coordinator of the Cardimed project, who will talk about nature-based solutions and water circularity. Then Efthymios Papachristos, a researcher and project manager at ICCS, who will focus on digital tools for NBS uptake for climate resilience and adaptation. Then Niki Frantzeskaki, who is a chair professor at the Utrecht University, who will talk about community resilience to climate change through NBS. And then Evina, Katsou, and Niki from Imperial College London, a professor and postdoc researcher accordingly, who will conclude the presentations. The last part of the webinar will focus on a discussion to reflect on how we can build water resilience through integrated approaches, combining nature-based solutions, digital innovation, social innovation, and WEFE and Nexus assessment. And it will be moderated by Tadej Stepisnik, who is a project manager at the National Technical University of Athens as well. So all of the speakers today have a role in Cardimed project. They are work package leaders and researchers, and we will try to give our experience of Cardimed project so far. I'm trying to move to the next slide. Okay, so a few practical things before we continue. This webinar is being recorded and will be uploaded to the YouTube channel of Cardimed project, and cameras are enabled. So if you don't want to be visible in this recording, please keep your camera off. The microphones will be muted until the discussion part. At this point, if you would like to ask a question, you can raise your hand and your microphone will be enabled by the moderator. And until then, just write your questions and comments in the chat, and we'll be really happy to hear your insights. So let's start with a few words about the Cardimed project. So Cardimed is the acronym of a project fully called Climate Adaptation and Resilience Demonstrated in the Mediterranean Region. And please feel free to follow us on the social media and to visit our website. I have an issue with moving the slides, so I don't know if Tadej, you can help me with that. I'm sorry for that, but all right. So thank you very much. Cardimed project is part of the EU mission adaptation to climate change, which is one of the European Union missions focusing on supporting EU region, cities and local authorities in their efforts to build resilience against the impacts of climate change. The project started in September 2023 and will finish in 4.5 years in February 2028. We are now relatively at the beginning. We are in the 10th month, but already we have several exciting things going on. We are 51 partners. We're from 14 countries, as you can see on this map, spread across Europe, but mostly focused also in the Mediterranean region. And our partnership, our consortium consists of universities and research institutes, SMEs and larger companies, NGOs, regions, municipalities, and local authorities and utilities. The vision of Cardimed is to enable the systemic transformation for regional climate resilience in the Mediterranean by unifying and mainstreaming NBS and other engineered infrastructure. This is why we focus a lot on the regions, and we have 10 regions joining our project, which is a very important part of the project for us. The project is based on four pillars, four main axes of research and applied innovation. The first pillar regards the digital technologies for climate adaptation. The second pillar regards socioeconomic resilience. The third pillar focuses on the water, energy, food and ecosystems nexus. And the fourth pillar on nature-based solutions. So our ambition and our biggest challenge is not to work on each of these pillars individually, but to look at them and connect them from a systemic perspective, to look at the solutions at a systems level. All right. So this is the part where I'm going to hand over to the first speaker, Simos Malamis from National Technical University of Athens and coordinator of Cardimed, who will talk about the one of the pillars, the nature-based solutions. And this is actually how this webinar is structured. So each of the speakers will focus on one of the aforementioned pillars of Cardimed. So thank you very much. And Simo.
Thank you, Alexandra, and good afternoon to everyone. I will go through 9 demonstration sites. Tadej, if you can give me permission. Yes, thank you. But before that, a little bit of promo of our group. We are the Sanitary Engineering Laboratory, and we are within the Department of Water Resources and Environmental Engineering of the National Technical University of Athens. Our group is very active in European projects, which is brings the vast majority of the income to our laboratory. We have been the coordinators of the DRUSA project, which I guess some of you know, on the valorization of non-conventional water sources at a decentralized level. And our laboratory is now coordinating the mission's Klima Cardimed project, as Alexandra mentioned. And here you can see an overview of other projects that we have, which are funded by EU. So now to the Cardimed demonstration sites. As Alexandra mentioned, our project focuses on the Mediterranean biogeographical region. So we have demonstration sites spanning from east and Turkey and Cyprus to the west part and Spain and Portugal. I will be focusing more on the sites that have to do with water, building water resilience and addressing water-related challenges, but I will also devote maybe one slide for other demonstration sites of the project. So the first demonstration site we was actually developed within the DRUSA project and is currently the vast majority of the infrastructure is already there, has to do with the valorization, the recovery and valorization of non-conventional water loops in the Aegean. Talking about Aegean, both the North Aegean Islands and the South Aegean Islands. So we have a number of, we have 3 demonstration islands, Mykonos, Lesbos, and Sifnos, where we have developed a variety of nature-based solutions. And I will go on to describe a little bit what we have done, which is currently also a part of the Cardimed project. So in Lesbos Island, we have developed a completely circular decentralized scheme for wastewater management of a village of 500 people. So here we have anaerobic treatment processes coupled with constructed wetlands and disinfection to deliver Class A water, reclaimed water that is suitable for unrestricted irrigation. And through this water, we have actually developed an agroforestry system combining trees, shrubs, bushes, and annual crops. And we also have the sludge treatment line that is treated by reed beds plus composting process. Here we have valorization of the water itself, the energy through biogas, the nutrients that are recycled from reclaimed water, and the compost. You can see here a scheme of the on the left of the actual wetlands, and on the bottom the anaerobic treatment scheme, and the photos of the sludge drying reed beds, the saturated constructed wetland, and the agroforestry. This is a view via drone, the main and the smaller scheme where we are developing a different type of plantation. Now moving on to the Mykonos Island subsurface rainwater harvesting system. Here what we do is we valorize through a novel scheme rainwater in a completely rural area in Mykonos Island, a very dry area. So you can see here a model of the scheme where we will with the collector of the water using no energy and the storage in the tanks in its use. We have online low-cost monitoring scheme for basic parameters, and the water is used for oregano cultivation and essential oil production. In the same island, we have developed a residential water management scheme where we valorize rainwater, stormwater, and runoff. We have rooftops to valorize rainwater, bioswale system to collect the runoff, and we use the recovered water for multiple purposes, which include residential use, non-potable residential use. We store it into the aquifer during the wet season to be valorized during the dry season, but also we use it for agricultural purposes. And what will be developed in the Simos Island is also some innovations, some stone-built weirs in order to decelerate the flow of the river and use this river water for different types of activities, including agricultural use. In demo 2, we are in an industrial environment and we are testing the industrial symbiosis through smart water management. Here we have solutions such as bioswales and biofiltration units. We're developing a digital twin, and we want to develop an almost real-time system where the water demand will drive the use of the water. In an industrial site, it's in Halkor industry, which is a major constructor, producer of aluminium, and here we and copper, and here we have a view of the facility of the industry. Some meetings which have taken place to decide on the area of intervention. Here we will valorize both the rainwater and the wastewater of the industry through a process of biofiltration to treat it and use it in the industry, but also we will have a swale system, a bioswale system to recover the runoff, again to be used here for urban irrigation, for green spaces. In the demo site 3, which is implemented in Italy, in Sardinia Island, we have a number of interventions leading to decarbonization of agricultural practices. So here we have 2 locations. One location is in the Alghero rural site, and the other one is in the Kalik Lagoon. And we want to decarbonize agricultural, livestock, and improve water, energy, and carbon use. You can see here in the slide that we have a number of NBS which include microalgae cultivation, constructed wetlands, riparian buffers, leading to the treatment of the agricultural drainage runoff. And then, according to the quality of the reclaimed water, it can be used for purposes such as aquaculture and for and we also test it for multiple uses. The results from the Alghero demo sites will then be used for the assessment and possible implementation of MBS to support the transferability of the main findings in the Kalich Lagoon. The demo 4 is in Sicily. We have again 2 locations, Catania municipality and the Ferla village. And here in Sicily, we will be developing a solution in order to address the pluvial flooding of the city of Catania and the center. So we are doing a full-scale intervention at the Tondo Genti location roundabout, consisting of a rain garden. You can see that the intervention area is quite big, and it's quite sensitive area where problems have been caused in the past due to flood issues. And here you can see some design aspects, some preliminary design aspects of the rain garden. It's basically a SAT system consisting of swales and bioretention cells. The green wall, which has been constructed and will be is also part of the Cardimed project, consists of a scheme that has been developed in Ferla for the management of grey water in a primary school. It connects very well to the stakeholders and the public, and is very well accepted by locals. In demo 5, which is in France, in Marseille, we have again solutions in order to prevent and address and mitigate floods. So we will have areas where we will have two demonstration areas, 2 interventions. You can see here where we want to address the challenges of heat waves and droughts and decrease the flood problems. So we will replace concrete with porous materials. We will have a soil and sealing, planting of trees and shrubs. And on this slide, you can see the what is currently the state. And on the bottom part of the slide, how we aim to change this through porous asphalt, through the plantation, through the use of swales, etc. Then moving on to some of the demos that are more related to ecological aspects and greening and biodiversity. In the region of Aragon, we have basically 2 areas where we will be addressing issues. Where one has to do with the greening of public schools. So we are developing an urban environment solutions in order to solve problems to mitigate heat waves, and the other has to do with sustainable forest management and addressing problems related to some parasites. In Portugal, we're going to the area of Alentejo, where it's in a region where it is scarcely populated and has water issues. And here we are addressing issues related to biodiversity, the control of invasive species. We want to do some riverbank restoration, and this area is an area that has heat waves, has seen precipitation decline and loss in biodiversity. As I mentioned, is very scarcely populated in Portugal. And the prime aspect here is ecological restoration of riverside and cultural landscapes, the so-called the HESES. In Turkey, we are in Izmir metropolitan area, and particularly the Gediz River Delta. It's a very sensitive ecosystem and a big one and very important one for Turkey. And here several solutions are taking place, supporting the issues such as biodiversity, the protection of species, and we have, as you can see, it's a protected area with many different populations, both important bird species, plant species, and we want to implement a variety of nature-based solutions to support habitat restoration. In Cyprus, we go to Nicosia area, and where we will be developing solutions related to mainly to water, but also to sustainable food production. So here we have rainwater harvesting, we have algal pond treatment for groundwater, hydroponic systems, and we will be developing this within the heart of Nicosia. And here you can see visualization of first pre-design of what we'll develop is basically an extension of the rainwater harvesting solution developed in Idrousa to be fitted in an urban environment. We also have the biodesalination process by algae. Here we also will involve locals in order to visualize and integrate within the actual NBS, the public itself. And to conclude, this is the aspiration beyond the project of Cardimed. We want to develop a very live alliance also through the other sister projects of Cardimed and another 6 projects, and build a live alliance in order to support the implementation of nature-based solutions to build climate resilience. So thank you very much, and back to you, Alexandra.
Thank you very much, Simo, for the presentation of Cardimed demos. Actually, our next speaker is planned to be Efthymios from Institute of Communication and Computer Systems, but I would like to ask you if it's possible to change a bit the order so that we can first hear from Niki, if Timo, it's okay for you.
Yeah, sure, no problem.
All right. So today we'll change the slides, and our next the next presentation is from Niki Frantzeskaki from Utrecht University, who is leading the work package on community resilience to climate change through NBS demos and social innovation.
Yes, thank you very much for this adaptation in the schedule. So we come to the question about how to build climate resilience in the Mediterranean region, focusing on the different demos that Simos already presented. And we also start from a very rich background. There's a lot of theory and a lot of case studies about fostering urban resilience. And in the work that we're doing in the Cardimed project, you can move to the next slide, Tadej, thank you. It is about focusing on community resilience. So building from theory and past also experience with the governance on NBS in cities and regions, we come with a proposal that community resilience requires a 3-tier approach. We need to see how and which means, which planning instruments and approaches can enhance the inclusive governance of nature-based solutions with a focus on mainstreaming, exactly given the different contexts that we are working on. Is not anymore on uptaking, it is more about scaling in different ways. So institutional mainstreaming is on the focus. The second area and the second approach is about investigating how nature-based solutions enable new meanings and new relations between people and place with a focus on social innovation. And as you saw in the different demos, the nature-based solutions, they actually create a transformation of place. That, of course, has an impact, not necessarily a negative one that needs to be mitigated, but rather a positive one that can be enhanced of how nature-based solutions are transforming and impacting place. And the third element that we are taking is what can we learn about community resilience if we not only look on the governance and institutions, the people-centered approaches that the social innovation research is arguing, but also bring the place into consideration. And place-based approaches to renaturing with nature-based solutions is also a way to unpack and understand community resilience. As we dive deeper today, maybe the next slide. Thanks. We are looking on inclusivity, going beyond just the cross-sectoral approach. Next slide, please. Building from research we have been doing in Connecting Nature project, but Tadej, can you move to the next slide? Thank you. Yes.
Yes, Niki, just to say you also have controls, I think. So if you want, you can also move them.
Okay, thank you. Sorry, I didn't notice that. So we look on inclusivity, taking what we call about a pluriform approach, looking on the cross-sectoral, the epistemological, the multi-species, the spatial, and intergenerational. This we find also from the reading of the policy documents now across all the demos, how different aspects of inclusivity have been stressed also in the agendas and in the plans of the local and regional governments of the Mediterranean demos. It doesn't move today. Okay, it moved. The second aspect is about the role of social innovation in fostering community resilience. And as the project is centering about water resilience and the role of water, the blue infrastructure in cities and regions, we will examine not only the visible blue infrastructure, as you see from the picture from Spain, but also the invisible water in our cities and the role exactly in regenerating urban spaces and regenerating nature. A focus on urban blue infrastructure, we find that is missing largely, not only from the way we understand urban resilience and climate resilience, but also from European Union policy, policy agendas. This is something that we want to investigate in terms of institutional capacities and understanding, new meanings, new also connections between people and place through water, and also how different social innovation networks can take different roles in fostering it. Next slide again. It doesn't. Okay, perfect. For this, we have a number of frameworks we are applying, especially looking on the emotional and the structural transformation of how the social can not only be a receptor, but can also be a driver on the mainstreaming of nature-based solutions. And to come full cycle on, this is quite of a novel theoretical approach, but it builds much more stronger, moving beyond the green into the blue infrastructures in the city, into the water nature-based solutions. We want to stretch how important it is to understand how people associate with the waterscapes in the city, what are the policy gaps that we already observing in the local regional, but also EU level policies, and how our project, looking on the place-based approaches we have in the demos, can actually inform for a stronger implementation of the European Green Deal and for a more cohesive and integrative implementation of the European Union Nature Restoration Law. And we find that our project can also demonstrate how you can bring different tools in the assessment, monitoring, but also progress in the debate beyond that, using the integrative social lens, but also the monitoring and, of course, the digital means and the digital tools in this. And that's it from my side. Thank you.
Thank you, Niki. So let's now move on to Efthymios Papachristos from ICCS, who will talk about the digital tools that are being developed in the context of Cardimed project.
Hello, everyone.
Just a moment, Timmy, we're fixing the slides. Yeah.
Nice. All right. Do I have control yet or not? I'm not sure.
Yes, it should work.
All right. Okay. Okay. Perfect. Right. So hello everyone. I'm Efthymios Papachristos. I'm working on the Institute of Communication and Computer Systems, ICCS, and I'm going to present you the digital tools that are going to be set up during the Cardimed in the frame of Cardimed project in facilitating NBS update for climatic resilience and adaptation. So the main objectives here are, first of all, to create a list of climate resilience indices for monitoring and assessing the efficiency of the nature-based solutions. Develop methods and instruments for the data collection, the orchestration of data, and then fusion of various data streams. Development of methodologies for upscaling these results to the regional scale in terms of NBS benefits, and finally to design the Cardimed digital framework for the uptake for experts and actors of the NBS local communities, municipalities. So first of all, how to build a strong data framework for the NBS uptake. Starting from the climatic indices, we need a solid catalog that has the indicators that help us evaluate the efficiency of the NBSs with respect to climate resilience. I have here some examples in biodiversity, forestry, soil water quality, etc. Then we need a very, very solid data collection strategy that ensures that the data we need for monitoring the NBS system, the nature-based solutions, are collected at the needed spatiotemporal scales, and also can be basically related to the indices we want to look at and evaluate our NBS solutions. Another step is the middleware, which is the intermediate part between partners and data sharing that ensures that data will be harmonized and will have a common format and can be easily distributed among partners. And finally, data fusion, which is actually the integration of the different data sets for describing the wanted quantities. So the first digital tool I'm going to present is the Cardimed NBS definition and scenario-based impact assessment interface, which is an interface that helps us get data, build up various scenario, run the scenario for the different NBSs, and evaluate them based on visualization outputs on the indicator results. The second tool we're planning to build through Cardimed is related to the diffusion of information. This will be a twofold dashboard. First, we have an interactive dashboard suite that is based on the input data and sensors and will give us a high-level panoramic view of the climate resilience indices and how they basically evolve and what real data and metrics we can get out of this data. And the second part is the dissemination data storytelling app, which will help in understanding better the NBS via engaging story-based dashboards on data and facts about each NBS and their results. And also it will let the user interact with the information on the screen. So this will help to better inform people about what is actually done in each NBS and what we're looking at and why. The third tool we want to build here has to do with citizen engagement, and it's based on this citizen engagement app and intervention content management, which is basically an application, cell phone application, a mobile application for citizens to get familiar with the NBS solutions. It will have several features that will help, first of all, to get the the citizens interested about NVIDIA solutions via impressiveness of features like augmented reality. And then we will provide other functionalities such as content management system, reporting, and also some educational features and tailor-made features for each demo so that the users can get closer to each NVIDIA solution on the demo and see what is practically done and why is all this done. The fourth digital tool has to do with MBS exploitation and transferability module, which is actually an application that in which the local stakeholders or policymakers can enter an area of interest. And so based on the type of challenges they have to face, it selects the most appropriate NVIDIA solution. It gives some guidance on how they should implement that and some more recommendations based on various data processing. So the thing I didn't speak about up to now was the upscaling part I mentioned before. So I will try to guide you through that. Upscaling has to do with taking the benefits from the local scale where the NBS are applied to on each demo site, for example, and evaluate that in a larger scale, in a regional scale. How we are planning to do that? We are basically focusing on Earth observation data, satellite data, but we're also planning to use other data streams like in situ data from existing sensors or new sensors, citizen data from like citizen engagement apps, for example, and region-owned data sets to augment our data set on in cases where the Earth observation data are not enough to describe the indices related to each NBS solution at the desired spatio-temporal resolution, for example, or if there's a missing data set related to that index. So I'll try to guide you through the sketch on the right, sorry, a little bit. So we start from a given problem, given climatic problem. We have a list of NBS solutions for this related problem. And then given the physical constraints of the terrain, climatological constraints, etc., constraints in data acquisition, for example, and the related climatic risk, we end up with a solution. Then from that, we observe the related data set from all the data streams I mentioned before, and we evaluate we have an index of efficiency of the NBS solution. Now, if we incorporate on that also assessment models and use all that into the upscaling methodology, we're planning to have an equivalent of, for example, a hazard map on a regional scale in which we're trying to reduce the impact of some climatic indices by a percentage or increase the benefit by a percentage. To give you a short example, sorry, one second. To give you a short example, we have here stormwater regulation NBS as presented by Simos before in demo 1. The applied NBS solution here was the storm weirs, and we are trying to see if we can set up a baseline scenario using Earth observation data. By doing so, we can follow the vegetation indices and water indices for the affected area by the NBS solution, but also through that we get some indicators that are for the broader region, which could be, for example, the seasonality. If you see on the right, you see one of the vegetation indices, and we can see that from there we can get the growing season for the specific area. Then we can use that and combine it with other metrics like rainfall or other climatological data and have information about even broader area and closer information related to the benefit of the NBS solution. Now, another good thing is that these methods applied here or developed here do not only apply on one NBS, but for example, they can be used. Sorry, my bad. For example, they can be transferred in other demos focusing on stormwater regulation or heat wave mitigation, which are priorities right now for this task. And you can see here, for example, the evolution of the land surface temperature on the demo of Marseille on 2 case studies, and you can see also the evolution of vegetation indices on the selected areas for intervention. So from there we can get some idea about seasonality and also about more specific indices regarding unsealing and greening of the city. So if we do all that, what we would like to have as an overview in the end would be the following educational, let's say, video. I'll show you now. So we start with an area of interest. Here we have Marseille, for example, and we go towards the specific region we want to intervene. We have an automatic classification based on Earth observation by satellite data. We select the appropriate solution, and then we have our sensors installed or crowdsourcing. We fuse them with Earth observation data as well, and we see what is the effect of all that on a regional scale regarding the benefits of the NBS solution that we selected. And with that, I think I will just stop here. Thank you.
Thank you very much, Efthymios. So at this point, we have already seen 3 of the 4 pillars, the NBS demonstrations, a 3-tiered approach to community resilience, and several exciting digital tools for community engagement and upscaling of NBS. And this is the time to go to the 4th one, that is the WEFE Nexus. And let's welcome Evina Katsou from Imperial College London, who will tell us everything about it.
Fantastic. Thank you very much, Alexandra. Let's conclude with the final pillar. And through this presentation, I would like to show you the method we are going to follow in order to build resilience through the WEFE approach by integrating water, energy, food, and ecosystems. Do I? I have the control. Perfect. So I am Evina Katsou, professor in water engineering in Imperial College London. Just to give a flavor about the activities we do, I lead the Center of Resilience, Circularity and Sustainability. And this belongs in the section of Environmental and Water Resource Engineering. It is in the Civil and Environmental Engineering department. My team consists of 25 research fellows, research associates, and PhD students. And we are working together in order to develop technological innovations across various areas of water, waste, food, energy, and resources. We also develop tools and methodologies for sustainability and circularity assessment. Now, all these efforts target Nexus assessment and resilience in order to ensure integrated and sustainable management of water, energy, food, and ecosystems. We have a good portfolio of projects, approximately 40 projects, supporting various industrial sectors with customized decision support tools. So let's start with what is the WEFE Nexus approach. It is a holistic framework addressing the interconnected challenges of water, energy, food, and ecosystems. Ecosystems are central to our water, energy, and food security. Just to give an example, agriculture, as we see here, consumes 70% of global water, and 90% of power generation is water intensive. At the same time, and this is an interesting fact, 41% of global irrigation water use happens at the expense of environmental flow requirements. The main action fields of the WEFE Nexus focus on three main goals: accelerate access to resources, foster economic efficiency, invest in environmental sustainability. The Nexus perspective emphasizes the need for integrated management and governance, and this is what we see also in the middle of this slide. However, there is an important question remaining. Is the WEFE Nexus a mainstreamed approach in decision making? So today, this is what we are going to discuss. We are going to see what we do in Cardimed project in order to promote the WEFE Nexus approach for water resilience. So the WEFE Nexus approach has not yet become mainstream in decision making, and this presents several challenges. Currently, decision making often happens in silos, focusing separately on water, energy, food, and ecosystem. This is a fragmented approach and several times leads to isolated solutions that fail to recognize the interconnected nature of these sectors. As a result, we see conflicting policies and inefficient resource use. We have seen that when sectors don't coordinate, we miss opportunities for synergies that could enhance sustainability and resilience. So instead of integrated solutions, we often end up with waste and suboptimal outcomes due to policy misalignment. Resource conflicts is another significant issue. When sectors compete for limited resources like water and land, tensions escalate and overall resource availability diminishes. Moreover, a narrow sectoral focus can also exclude key stakeholders, undermining comprehensive and inclusive decision making. By highlighting all these limitations, we make a strong case for adopting this WEFE Nexus approach. Let's explore how the WEFE approach offers a transformative path to overcome sector-specific challenges and promote integrated decision-making. The Nexus approach emphasizes efficient resource management, optimizing the use of water, energy, and land to ensure that the needs of various sectors are met sustainably. At the same time, the WEFE Nexus approach balances water allocation, thus reducing conflicts between agriculture, industry, and households. It promotes coordinated planning to optimize land use and prevent conflicts. And this ensures that the harmonized policies are in place for coherent and effective governance. This approach enhances resilience against climate change and supports sustainable development, paving the way for a more resilient future, fostering integrated decision-making and building resilience across various sectors. Not moving? Okay. So we will see now, and we are going to have a look at the consequences of sector-specific decision-making using Mykonos Island as a real case study. Before tourism, Mykonos had an agricultural economy with local food production sustaining the population. However, prioritizing tourism has disrupted this balance. So today, Mykonos relies heavily on tourism, and authorities focused on tourism's economic benefits without considering water, energy, and food security, and this has led to several issues. First of all, water scarcity. We have high consumption by hotels, swimming pools, and tourists, especially during peak seasons. Also, over-extraction of groundwater that has led to saltwater intrusion. Energy challenges at the same time. So the energy sector has emphasized meeting the high demand from tourism without adequate investment in renewable energy sources. And at the same time, the agricultural sector has been neglected, with local agriculture struggling to compete with tourism. And finally, we have the ecological damage from population and inadequate waste management. So this example underscores the WEFE Nexus approach importance for sustainable development and resilience. Integrating water, energy, food, and ecosystems can create a balanced and sustainable future for Mykonos and similar regions. So the impact of sector-specific decision-making on local communities in Mykonos is significant. And here we see how our Cardimed demos in the island address these challenges, focusing on residential, agricultural, and environmental solutions at micro level. So concerning residential initiatives, we use rainwater for domestic non-potable uses to reduce centralized water demand. Agricultural practices, so we aim to regenerate local food production by using rainwater and stormwater for irrigation and employing precision irrigation techniques. And finally, concerning environmental initiatives, we combat saltwater intrusion in groundwater through artificial recharge. Although these sub-demos are implemented at micro level, targeting individual buildings and agricultural fields, their impacts can be broader. They enhance water resilience and agricultural regeneration across the island, especially if scaled up. So the success of these solutions depends on policy support and appropriate incentives for individuals in order to adopt them. Guiding, budgeting, and resource allocation through the Nexus approach can definitely provide this support. So we need holistic project assessments in order to identify synergies and allocate resources to initiatives with multi-sectoral benefits. Comprehensive impact evaluations and adaptive management strategies can minimize negative impacts and ensure responsive planning. Aligning budgeting with policies supports sustainable development and, of course, environmental protection. This integrated approach leads to long-term sustainability and resilience through no-regret solutions that yield benefits under a wide range of future scenarios. And by following these guidelines, the regional authorities can create a robust framework for sustainable development and ensure the success of the WEFE Nexus solutions at all levels, micro, meso, and macro. Let's now discuss an example of how different projects impact the WEFE Nexus. The type of information provided by this exercise includes identification of cross-sector interconnections, such as energy and ecosystem health, and detailing primary objectives, enablers, barriers, and key functions of the projects. It also outlines the expected positive and negative impact on various Nexus components, such as water, energy, food, biodiversity, ecosystems, and soil, since most projects would have both positive and negative impacts. Additionally, it highlights the required resources, involved stakeholders, scalability potential, innovation level, replication readiness, policy alignment, and monitoring strategies. With this comprehensive overview, we are able to understand the multi-phased effects of projects and prompts us to question if this information alone is sufficient for making informed decisions. So in order to ensure sustainable and integrated resource management, it is very important to combine this project specific data with broader regional priorities and objectives. The next step is to see whether the projects align with regional priorities, which can facilitate the provision of incentives and support, ensuring that the objectives and impacts are harmonized with the region's needs. Building on the understanding of project-specific impacts from the previous case, from the previous slide, here this example illustrates the critical regional information needed for informed decision-making. It showcases how different agencies within a region have varying priorities, targets, and challenges. For instance, Agency 1 prioritizes improving water quality by 2025, while Agency 2 focuses on reducing soil erosion by 30%, and Agency 3 aims to increase renewable energy share by 2030 to 50%. All these priorities must be balanced against budgetary constraints, identified areas of intervention, current projects, local governance structures, socioeconomic characteristics, and key stakeholders involved. For example, the project example of the previous case, while beneficial for reducing carbon emissions and increasing renewable energy production, poses potential conflicts such as land use issues, water usage, and potential pollution. Aligning such projects with regional priorities and considering the trade-offs ensures that projects support sustainable development. So this comprehensive approach emphasizes the need for integrating project-specific impacts with regional priorities to foster balanced and informed decision-making, ultimately promoting resilience and sustainability across sectors. We are now transferring this approach to one of our Cardimed demos located in Lesbos Island. Actually, this was described by Simos, so I will discuss it very briefly. So this demo is a wastewater treatment plant that treats domestic wastewater from the Adisa village using anaerobic treatment and constructed wetlands, followed by ultrafiltration and UV. The reclaimed water is used to fertigate an agroforestry site in which a great variety of crops, herbs, and trees are cultivated, and which is located in the surroundings of the plant. Additionally, the biogas generated in the anaerobic treatment is used to produce energy, and the sludge is used to produce compost. In this demo, all the components of the WEFE Nexus are highly relevant. So let's have a closer look at the qualitative Nexus analysis of this demo, as well as the contribution or implications for sustainability and resilience. When examining the qualitative results, we see here in the table the plus and the minus. It becomes apparent that this demo mitigates the conventional trade-offs among water, energy, food, and ecosystems, fostering synergistic relationships instead. The outcome of this demonstration lies in its profound positive influence on both water and ecosystem resilience. Specifically, we observe here significant contributions, such as the production of renewable energy and the reduction of carbon footprints through the treatment of wastewater for energy production. Additionally, the use of reclaimed water for irrigation leads to substantial freshwater savings and increased food production efficiency. The agroforestry practices, instead of monocultural production, further enhance biodiversity, improve ecosystem services, and promote carbon sequestration. By softening the interlinkages between these critical elements, this initiative not only enhances the sustainability of our resources, but also paves the way for water and ecosystem resilience. Here we have extracted a table from the analysis that summarizes the regional challenges and targets where this specific demo is implementing, highlighting the critical interplay between water, energy, food, and ecosystems. The synergistic relationships fostered by this demo show a strong alignment with many regional objectives. For example, the demo significantly contributes to sustainable development by preserving water, nutrients, and biodiversity, aligning with the regional priorities for environmental protection and water management. The production of biogas from treated wastewater and the promotion of sustainable agriculture support the renewable energy targets and the circular economy principles. At the same time, the use of reclaimed water for drip irrigation addresses water scarcity issues and enhances resource management that is a critical regional challenge. Our goal to this demo in Cardimed is to perform a regional assessment by upscaling it so we can quantify and investigate the impacts and contributions it can provide to the island of Lesbos. So here you can see our Cardimed sub-demos and their alignment with the WEFE Nexus approach. As Simos said, the Cardimed consists of 9 demos and 19 sub-demos spread across 7 countries, addressing different aspects of the Nexus in rural, urban, peri-urban, and natural landscapes. So the Nexus Group 1 focuses on the water, energy, ecosystem interconnections, implementing one demo, Demo 2, to highlight this synergy. The Nexus Group 2 integrates water, energy, and food considerations through the 3 sub-demos, emphasizing sustainable agricultural practices. The Nexus Group 3 addresses water, energy, ecosystem dynamics, featuring 5 demos to improve ecosystem health and resource efficiency. And the 4th group combines energy, ecosystem, water, and food elements demonstrated through 3 sub-demos and Demo 3, aiming for comprehensive resilience. Our demos are implemented at different scales, such as buildings and neighborhoods, but we need also to see the importance of investigating the Nexus impacts at different scales. Many projects start small, like at a building or a company level, where the WEFE Nexus components directly impact the individuals involved. However, in order to be able to address the broader implications and benefits, we needed to look at the bigger picture. So scaling up these projects can align them with regional priorities and objectives, which might attract incentives and support. With evaluation of projects' impacts on the regional nexus, we can assess its contribution to long-term sustainability and resilience. This broader perspective ensures that small-scale implementations benefit individuals while also supporting societal goals. And finally, by harmonizing human-driven and nature-driven processes across larger spatial scales, we highlight the importance of policy influence and coordinated efforts. This approach maximizes the positive impacts of projects within the Nexus approach, focusing and supporting a sustainable future for both individual and communities. So, to effectively implement and scale a WEFE Nexus projects, continuous monitoring and data integration are crucial. Monitoring changes in resource availability with technologies presented before by ICCS, like remote sensing and IoT sensors, enables timely interventions. Integrating data through big data platforms, GIS and artificial intelligence provides a more comprehensive Nexus understanding. At the same time, evaluating projects helps the identification of best practices, and we are able also to inform policies. Scaling the successful demos with strategic partnerships and funding can maximize benefits. This approach ensures WEFE Nexus projects contribute to sustainable development and resilience, and this is the approach we follow in our Cardimed project. It is a previous one. I had the conclusions today. Just to go back. Fantastic. So to conclude, adopting the WEFE Nexus approach necessitates policy recommendations, and thus this is what we are going to do through the project in order to enhance resilience and sustainability. Key policy recommendations from the project and from this Nexus approach include promoting integrated resource management, investing in sustainable infrastructure, practicing adaptive governance, and this is very much in line with the EU adaptation strategy, data and technology utilization, and stakeholder engagement. So the Nexus approach should improve resource efficiency, enhance risk management, and achieve long-term economic resilience by reducing environmental impacts and building robust systems. We can effectively address challenges and ensure sustainability. And this involves diversifying resources, ensuring redundancy, and empowering communities. Integrating now all these strategies promotes water, energy, and food security, economic stability, and environmental protection. Whether on a small or large scale, this comprehensive approach supports sustainable development and resilience. And this is the approach practiced in the Cardimed project. Thank you very much.
Thank you very much, Evina, for the presentation and for essentially connecting the WEFE Nexus to the three other pillars, the NBS demos, community and policies, and the importance of data and upscaling. So with this, we wrap up the presentations, and I hand on to Tadej, who will guide the discussion on the reflections regarding water resilience and how it can be built through integrated approaches.
Thank you, Alexandra. Sound check if this works good.
All right, fantastic. And I stopped sharing screen so that I can see also every participants here in this webinar. Thank you also from my side for everyone attending. We are quite a nice number of listeners, and basically this is an opportunity for attendees to ask questions in case any of the presentations has triggered any thoughts, in case you're working on something similar, in case you're a region or an authority that would like to know more. You're very welcome to ask questions. When it comes to the housekeeping rules, still for now everyone is muted. And in case you would like to ask a question, you can either type it in the chat or raise your hand, and we can give a word, also enabling microphone one by one. I would very quickly check if Niki is still with us. I believe she's not, and I think I don't see her anymore. She informed us that she might. I had an interesting question for her. Yes, and she's not here. But again, in case any participant has a question, even for someone that is not here, you can type it in the chat and we can potentially address it later. As Alexandra mentioned, this webinar will be also posted on YouTube, so it can be rewatched and we can respond to the questions later in writing. I will meanwhile also check my notes because I was doing many notes in between, and a couple of things has triggered my attention. So perhaps to break the ice, I would have first question. It could be for Simos or anyone who would be willing to answer, and perhaps also someone from the audience is welcome to answer questions as well. So my thought was, Simo, that water management in Europe is quite regulated, and I would be interested to hear if EU policies or EU directive are actually enablers, or are they accelerating or helping implementation of nature-based solutions, or are they perhaps hindering it or slowing it down? How easy it is to implement nature-based solutions?
Yes, thank you, Tadej. I would say yes and no to your question. I mean, the EU policy recognizes the importance of integrating nature-based solutions within the European Green Deal. It is mentioned clearly that NBS can support climate adaptation, and also in the EU climate adaptation plan, it is also again there mentioned that directly that implementing nature-based solutions at a big scale could increase climate resilience. Also in biodiversity strategy of EU, there also NBS is mentioned that can have multiple benefits related to the support of biodiversity. The issue is that when we go into the actual directive, let's say the Urban Wastewater Treatment Directive, and it's the recent proposal for that is upcoming regarding that will be the new directive for Urban Wastewater Treatment Directive and the water reuse regulation. NBS are not mentioned. Of course, there are the technologies specified are the typical secondary treatment technology or technologies that treat at least up to that standard. So basically, we need to have proofs and evidence that these technologies are treating to the standard we want. And this is why such projects and previous projects are important in order to have this evidence. I think that on the other hand, though, although not directly mentioned in some of the key directives, the upcoming legislation is has opportunities for NBS implementation because it talks about wastewater treatment plant neutrality. Constructed wetlands have a very low energy requirements. It talks about post-treatment in order to remove emerging contaminants. It talks about decreasing the population equivalent from 2,000 to 1,000 in terms of servicing sewage, the population for sewage and treatment, where nature-based solutions can have a very pivotal role. So there are opportunities even in cases where NBS are not directly mentioned.
Thanks for the input and explaining a little bit more on this. I see the question in the chat by Andrea, and perhaps I invite Timos to look at it. But before going to that question, because perhaps it's a little bit related with what I asked Simos, I would have a question for Evina. And you already addressed the topic to some extent, that in fact most of the European projects, as well as in Cardimed, in fact, we are developing the solutions on a small scale. So we have to define where we have a solution, and it's this park or it's this water stream. But you also mentioned indeed the importance of evaluating the impact on a larger scale, on a regional scale. And that this is then useful for regions and for policy suggestions. So how easy it is actually to do the impact assessment of Nexus on a regional scale, and how can this be done?
Thank you very much, Tadej. Actually, this is something very important, and this is something that we wanted to demonstrate through the project, because working at different scales, starting from a small scale and going through the process of the scale up, it is quite challenging. But at the same time, it's very crucial, and especially for broader policy and planning. So actually what we are doing in the project is to implement a structured approach to upscaling. And this involves first contextualizing microscale data in order to account for regional variations in environmental and socioeconomic conditions. Then implementing projects at intermediate scale, such as the demo case that we saw in Lesbos and the other demos that Simos presented, can definitely provide critical insights into the scalability and the practical challenges of these solutions. Now, at the same time, aggregating and synthesizing data from multiple small-scale projects is also necessary in order to identify patterns and synergies, and this can be extrapolated. Now in Cardimed, we're also going to integrate modeling and simulation tools. That is also important, where detailed data from these models are used in order to build and refine the models that simulate the regional scale interactions between the water, energy, food, and ecosystem components. And also we are going to apply uncertainty analysis in these models that helps to manage the potential risks and variabilities in order to ensure a more reliable prediction. So to summarize, through this approach and leveraging small-scale data, demo data, it is a powerful means in order to assess and plan for the regional scale impacts of the WEFE Nexus. And we believe that this is going to give critical insights for policy and decision making. So this is a structured approach that we are going to follow in the project.
Yeah, make it quite clear. Thank you, Evina. So we have a question in the chat by Andrea Ramirez. I will read it out loud. Can you please explain more about the data storytelling component and if and how it is linked to social innovation? Now, I can already say that I directed this question to Efthymios, but I know that he's not actually the partner developing neither data storytelling, and social innovation is related, or it's work led by Niki Frantzeskaki. So I'm not sure if it is an easy question to tackle, Efthymios. I give first word to you, or perhaps if anyone else also would like to give an input.
All right, so I'm definitely not a specialist on that. So from my perspective, I think it's just a way to engage non-technical community and make it clear to them. And for example, if you have a benefit index related to air quality or I don't know, CO percentage, for example, it would mean nothing. But if you make that in a more high level storytelling example, maybe you get more people involved, and it helps in this way in social innovation. But I don't know much details about that, so I'm gonna ask if someone else knows more. It can help.
I think actually you made quite a nice point. And again, if someone from other panelists wants to say something, to add or summarize, indeed what we see in Cardimed, or what we will try to do, is to translate the technical knowledge and scientific knowledge to make it understandable by citizens and population, because most of the times, indeed, the nature-based solutions are implemented in public areas. So data storytelling is one of the tools that we are betting quite a lot on. Storytelling has proved, or it shows results that can bring complex topics closer to population and have them engaged. And perhaps we can indeed explore a little bit closer this topic, but another thing that we try to really, we will try to achieve in Cardimed is to empower local communities through fostering social innovation. So the topics, I think, link mostly with translating the knowledge and empowering local citizen scientists to take action. And thanks, Andrea. Perhaps we will also ask Niki for a short input on this. If no one else has a comment on this, I do, and since we were talking with Simos, I had a thought when presenting your work on digital tools. And Cardimed, this project, is a part of European mission on adaptation to climate change. And the main, let's say, beneficiaries, or how the target group that in a long term we want that benefits from this project, are the regions and other municipalities to improve their resilience. So you were mentioning and presenting briefly the tool for transferability. And indeed, it looks very interesting. And in my opinion, it looks very interesting also for regions or new regions that are not part of our project, but indeed one of the things that can be used by new regions. You also mentioned quite a lot of data, sensors, data streams. And I'm wondering, how much data is needed to use, let's say, a transferability tool, and how easy or how can other regions uptake such a tool?
All right. Okay, so thank you for the question. So starting from it, okay, for sure, there are things that are unique on each region, so we cannot go directly and apply everything on another region wherever we want. That would be amazing and very nice. But there are things and patterns that we can use on the already developed tools, or the to-be developed tools, to other regions with sometimes minimum impact, minimum new input on it. So I would say that it's in between having half the job done and needed some more inputs. For example, you might need region-owned data that you cannot have it, or if you stay on a similar climatological regime, it might be very easy. But if we want to apply it in a very different region, maybe then we'll need a lot of data. So it will depend, but I think we will have a strong basis, and then maybe, I don't know, adding some more sensors or engaging some citizens on a different area to get some missing data would do the job, and we can apply it probably.
Right. Yes, I'm not a digital person, so I am usually with curiosity following your work. It did strike me quite interesting that a lot of data sources are already available, or where I was following, you were collecting things that in fact regions also have a lot of data or catalogs already. So half job done, as you said.
Sorry, again, I missed the last part.
No, it was a summary of what you said, so it's not a follow-up question. I hope I'm audible okay. Again, a short ping to the crowd in case any new questions are appearing. We're still accepting them. While waiting for hands raised or questions in chat, I didn't miss anyone. And on the seemingly hard work and a lot of data requirements, I would turn back to Evina, and perhaps a question on actually water, energy, food, and ecosystem nexus, the approach itself, and perhaps an outlook of how can this approach act as an enabler for water resilience, and while seemingly that it has really a lot of potential to enhance water resilience, how come that it's not really widespread yet, or that it's not mainstream yet?
Yes, thank you very much, Tadej. And actually, yes, it is true that we have seen several projects on the water, food, energy nexus on assessments addressing different systems, different scales, and in principle, and from the terminology, let's say, the nexus approach enhances water resilience by promoting integrated resource management, acknowledging interdependencies between water, energy, food, and ecosystems. So all this holistic strategy optimizes water use, reduces risks, and encourages efficient practices, as we saw in the presentation, renewable energy, integration, precision irrigation, the use of reclaimed water, as we saw. So by fostering this cross-sectoral collaboration and leveraging technology, the Nexus approach can ensure sustainable water management and to make the systems more adaptable to climatic variability and several other stressors. But despite all this potential and all these benefits, it faces challenges. First of all, it is the sectoral silos and governance that hinder integrated planning. Traditional frameworks that resist cross-sectoral collaboration. This is one of the most important aspects. Lack of awareness among the stakeholders, the need that we saw a lot of discussion around data, so the need for robust data collection and all these advanced tools that we need that pose additional barriers. And some other constraints are financial. Of course, the complexity of managing diverse datasets that further complicate the implementation. So we have all these barriers, and at the same time, we have the institutional barriers that require new governance frameworks for a multi-sectoral engagement and policy alignment. But we are very much optimistic with the work we do that we will overcome all these barriers.
I hope as well, or actually I'm pretty sure as well. In my opinion, also Nexus is well, it offers this holistic view, and even if the analysis itself is scientific, and this is good that it's scientific and complex, the results or the impacts can be translated to very clear synergies or trade-offs, really clear connection between impacts. So while the assessment should be done by scientists, the users don't have to be, and I think this is a strong point. I would, at this point, maybe give a spotlight to Alexandra. Alexandra has just returned from Berlin, where she was last week on a very large event, not a European one, if I'm correct, but a global one, called "The Nature of the Cities," the nature in the cities, the nature of cities, I think. Yeah, and so would you perhaps could link what are the trends when it comes to the nature of cities in Europe or globally, and perhaps how Cardimed is positioned with what are the other initiatives right there, and maybe how big was actually the festival, the event?
Yeah, so it's a global community that's been running this festival for years online. So it was the first time that it happened. It took place physically. It was in Berlin, which was a very inspiring location actually, because there was the opportunity to really see a very green city, and the urban planners and the people from the department really showed how they have taken the plans, all the urban plans, and have implemented them into the city. So this community of the Nature of Cities Festival has a lot of artists involved. So it's artists, scientists, and urban planners. So this art part we're definitely missing in Cardimed, but who knows, maybe in the next years we can somehow integrate it. But I think we bring a lot of value in this discussion, because we're really showing how nature-based solutions can be implemented in action, in practice on the ground. Yeah, the trends that were really throughout the event were regarding biodiversity enhancement and rewilding, in general, a lot of wild spaces, wild nature, how we can go beyond the curated nature and urban spaces, more towards the reviving the wilderness. And it was also interesting to see a session of Urbes project. It's a project that finished 10 years ago, and its focuses on urban ecosystem services. So they invited all the cities that participated, and they gave the reflections of how the project supported them. So hopefully in 10 or 15 years, we can have a similar session with Cardimed to see the evolution of our demos.
Thanks, Alexandra, for sharing the highlights. Invitation for everyone to follow perhaps next editions. And since I don't see yet any questions in the chat, thank you for comment though, Marco. And we are very happy to perhaps stay in contact with the Regional Activity Center of Barcelona Convention, simply to share progress or perhaps ideas or inspiration. With this, I would actually link the discussion toward the mission adaptation to climate change. And in fact, for listeners who are perhaps from regional or local authorities, to take a look at the mission. So Cardimed is a part of this mission on adaptation to climate change. And what we try to achieve is that by 2030, I think the target is 150 regions, European regions or communities, become climate resilient and try to guide them. So the mission itself also has an online space and the adaptation and the mission adaptation platform, which is really a source of knowledge, a lot of tools, resources, and information that regions or local authorities can use on their path to climate resilience. It is also a place for networking. So Marco or others, there are a lot of other institutions or fellow regions or authorities that are being active on the mission adaptation platform, Meet for Adapt. I posted a chat a link to this mission in the chat if anyone is interested. And perhaps to have a long view of Cardimed project as well, we are happy to say that we're working very actively on those 9 demos or demo clusters on 19 different locations. But the end goal is again to collect and package this knowledge and transfer it to the new regions. So within Cardimed, we're also having 5 other regions that will start working on their climate resilience with the tools that we're developing. And we are onboarding additional 10 regions that can express their interest, that will be invited to participate in an online program as well on a lighter scale and start benefiting from Cardimed actions. As Alexandra mentioned at the beginning, the project is in a starting phase, so replication activities has not started yet, but you can keep an eye. You can check also our webpage, subscribe to the newsletter, and when those tools will be available for regions or for applications, you are very welcome to reach out to us. So I'm posting also our webpage where you can access also the newsletter and be informed of what we're doing. I am giving the last word to either panelists or the crowd for potential interventions, questions, or last thoughts before we will close this webinar.
So thank you everyone very much for joining. Thank you to all the speakers who presented all these exciting concepts. And we hope to stay in touch for the next years through the Cardimed project and nature-based solutions. Have a good afternoon.
Thank you.
Thank you very much.
Have a nice afternoon.
Thank
Bye-bye.
you. Bye. Bye-bye.
Bye.